Now in this example, we'll be looking at how we can solve, or rather how we can divide a polynomial function using a method known as synthetic division. Now I'm going to use the same example that I used for the long division, so you can look back on the long division video if you choose, but this one is synthetic division. Now first thing we have to do, we have to look at x minus 1. It's being divided by x minus 1, so we're going to equate that to 0, and then we're going to solve for x. So as you can see, if x minus 1 is equal to 0, therefore x must be equal to 1. Now what we're going to do next is look at all these coefficients: 2, 3, -2, and the constant -3. Now when we look at all of those, we are going to write them back as 2. Let me get some space. +3, -2, and -3. Now looking at all these numbers, we're then going to make a little bar here, make a line here, and then we're going to put 1 right here. Same 1 from x equal 1 up here. So when we have this one, we're then going to, first thing, put the first number down under the line. And we're going to say 1 times 2, 2. 2 plus 3, 5. Then we're going to start over. 1 times 5, 5. Add them, 5 plus -2, +3. Then we're going to say 1 times 3, 3. Then add them, 0. Point to note, the last number will always be the remainder. So given that in this case the remainder is 0, it simply means that there is no remainder. And if we go back up here for a second, we realize that the original function has the highest power being 3, a cube. So what we're going to do, we're going to start with 1 less in the answer. So if it's 3, the highest in the answer should be 2. So let's go back to the answer. So it will be 2x squared. And given us a +5, it will be plus 5x plus 3, and then of course remainder 0. So this would be the quotient. And that's how we do synthetic division.